Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on sequences and series for Mathematics Grade 12, Part 4, and that is a chapter overview. In Part 1, we focused on the arithmetic series. In Part 2, we looked at the geometric series, and in Part 3, we looked at the quadratic sequence. And in Part 4, we're looking at an overview, which is a summary of all the sequences and series we've looked at in this chapter so far. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on any new videos we upload in the future, and particularly if you like the contents of this video. We have a lot to cover, so let's start. Part 1, we're going to look at a summary of the arithmetic series, and in Part 2 of this video, we're going to look at the summary of the geometric series. Part 3, we're going to look at the summary of the quadratic pattern, and then finally, number 4, we're going to look at examples from past exam papers that include all types of these types of sequences and series. Now, starting with the summary of the arithmetic series, remember, an arithmetic series is a series where the constant difference between any two consecutive terms is a constant. You can either call that a common or a constant difference, and that is denoted by D. Now, the general term of an arithmetic sequence is Tn equals to a plus in bracket n minus 1 times D, where a is the first term, n is the term number or the number of terms, and then D is the constant or common difference, and Tn is the nth term. Now, the general formula for determining the sum of the first n terms of an arithmetic sequence or series is determined by whether you know the last term or if you do not. Now, if you know the last term of that sequence or series, you use the second scenario, the second formula, which goes n over 2 in bracket a plus l. Multiply by that. So where L is the last term and A is the first term, N is the number of terms or the term number. Now, the first one is when you don't necessarily know what the last term of that sequence is going to be. So you use a formula that is almost identical to that of the nth term, and this is how they are different. So the sum of the first n terms, when you do not know what the last term is going to be, even when you do know, that will be n over 2 in bracket 2a plus in bracket n minus 1 times d. All of that is multiplied by n over 2. Now, notice that this is almost identical to the formula for the general term. The only slight difference is that you multiply the a by 2 over here, and then you multiply the whole scenario by n over 2 outside of it. Now, let's look at the summary of the geometric series. Remember, a geometric sequence is a sequence where the constant, the ratio between any two consecutive terms is a constant. In other words, if you divide Tn by T1, which is a term previous to it, you should find a ratio that is constant regardless of whatever consecutive terms you're looking at. Now, the general term of a geometric series is Tn equals to a in bracket, a times r to the power of n minus 1, where a is the first term and r is the constant ratio that we talked about, n is the term number, and Tn tells you the nth term. Now, to find the sum of a geometric series, we've got 3 scenarios, and depending on the scenario that you're dealing with, the sum of the first n terms that you use should be and could be different, just to make your calculations a whole lot easier. Remember, you can use any of this. For the first and the second one, let's look at the difference. The first scenario, the sum of the first n terms is a in bracket r to the power of n minus 1 all over r minus 1. You start with the r and then the 1 follows after that. Now, this scenario you use when you've got r, your constant ratio, is greater than 1. Now, when it is less than 1, when r is less than 1, you use the second one. It's more appropriate and so much easier to work with, especially when you're calculating all those exponents. It makes it so much easier when your constant ratio is less than 1 and you use the second scenario. Remember, you can also use the first term You can interchange, it's not a problem. It's just easier when your r is greater than 1 to use the first one, and when your r is less than 1 to use the second one. Now the second one says sum of the first n terms equals to a in bracket 1 minus r to the power of n over 1 minus r. Now notice the differences. In the first one you start with your r's, in the second one you start with your 1. That's the difference. Now the last scenario, third scenario, is when you have what we call a convergent geometric series. What is a convergent geometric series? A geometric series converges when your constant ratio is between 1 and negative 1. It is a fraction between 1 and negative 1. So when you have a convergent geometric series, we have what we call the sum to infinity, and the sum to infinity has got the formula a over 1 minus r. That's it. Where a is the first term and r is the constant ratio. Obviously that will be a constant ratio that is between 1 and negative 1. So if they ask you a question, determine whether this geometric series is convergent or divergent. Now it will be convergent if your r, the constant ratio, is between 1 and negative 1. If it's outside of this, whether it's bigger than 1 or less than negative 1, then you have what we call a divergent geometric series, meaning it does not have a sum to infinity. Number 3, let's look at the quadratic series, the summary of a quadratic series. Remember, a quadratic sequence is a sequence of numbers in which the second difference between any two consecutive terms is a constant. The second difference that we're talking about is this difference. The third row, we've got the first row, the second row, and the third row. The third row should be a constant, and I'm going to show you exactly how we find that. Now the general term has got two levels for a quadratic series sequence. The first level is what I call the general term, and that is Tn equals to an squared plus bn plus c. Notice that you've got three variables here. The first one is a, the second one is b, and the third one is c. The second level of general term is one that is specific to a term number. For example, the general term for the first term is a plus b plus c. For the second term, it's 4a plus 2b plus c, and so on and so forth. Now, the first level of differences, right, is what we call an arithmetic sequence. They form an arithmetic sequence with the constant difference as the third level of differences, or the second level of differences, which is your constant 2a at the end. So this 2a, not only is it a second difference of the quadratic pattern, but is the constant difference of the first level of differences, which forms an arithmetic sequence. So this level forms an arithmetic sequence. Remember that and keep that in mind, because the two are usually related to each other, and you can calculate vice versa from one to the other and back to the other. Now, for examples from past exam papers, this is the last section. Let's look at question 2. 2.1 says 7xy and negative 11 ... is an arithmetic sequence. It's an arithmetic sequence in AS. This is an arithmetic sequence. Determine the values of x and y. We've got two unknowns, variables, that we need to find. So meaning that we'll end up with a simultaneous series of equations, which have to be two at least, so that we can find the answers of those two variables. So you've got two unknowns, and we will need two simultaneous equations in order to find the answers to both of them at the same time. So this is question 2. This is question 2. Question 2.1. So we've got the arithmetic sequence, and that is x. Sorry, it is. I think it is. Let's go back. 7xy negative 11. 7xy negative 11. 7xy negative 11. 7xy negative 11 dot 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 dot. We're supposed to find the value of x and the value of y. So that's what we're supposed to find. Alright, so what we do, remember the definition of an arithmetic sequence is such that the constant difference between any two consecutive terms should be a constant. So meaning that T2 minus T1 must be equal to T3 minus T2. And we'll make that our equation 1. And you will see why we make that equation 1. So now let's substitute the values. So that will be x minus 7. And that will be equals to y minus x. Take the x's to the same side. And take everything else to one side. Therefore, we've got 2x equals to y plus 7, and that therefore gives us x equals to, you divide both sides by 2 and you end up with that. So that is our equation 1. Now to find equation 2, let's use term 2, 3 and term 4. So we've got T3 minus T2. T3 minus T2 equals to T4 minus T3, and that will be our equation 2. Therefore, T3 is y minus x. Remember, these are simultaneous equations. You can find or solve them anyhow you like. There are 3 methods or ways of solving simultaneous equation. You choose whichever works for you and use it. So that will be negative 11 minus y. That is the last one. Okay, take the y's to the same side, or we can, have x on its own. It's up to you how you want to do it. So method 1, you can make x the subject of the formula and then equate the x's, or you can make y the subject of the formula and substitute it. It's up to you exactly how you want to do this. I prefer the x method, so let's take the y's to the same place and the 11, and then we have x on the other side. So that will be 2y plus 11 equals to x. Therefore, 2y plus 11 equals to x. And now we've got x from equation 2, and then we've got x from equation 1. Now let's equate the two. Equate the two. Equate 1 to 2. Therefore, y plus 7 over 2, that is the left hand side. Y plus 7 over 2 equals to 2y plus 11. 2y plus 11. Multiply throughout by 2 to get rid of the fraction. 2y plus 11. Alright, so that will give us, the 2's cancel out over here. The 2's cancel out over here. We're left with y plus 7. And over here we're left with 4y plus 22. Take the y's to the right hand side and then numbers to the left hand side. So we've got 7 minus 22 equals to 4y minus y. That leaves us with 3y on the right hand side, and on the left hand side we have 7 minus 22. Please always use a calculator just to double check your numbers. The goal is to make as few, if possible, mistakes, silly mistakes, so we can avoid losing marks because we made an error that messed up our answers, and therefore we'll lose marks. 7 minus 22 equals to, that gives us negative 15. So that is negative 15. And now we divide both sides by 3. So that's negative 15 over 3. That is y. 3y over 3. The 3's cancel out over here. and negative 15 divided by 3, that is negative 5, and that gives us the value of y. Now we take this y and substitute it back into any of the equations for x. Okay, now substitute into any of the equations. Okay, let's substitute this into equation. We can substitute it into equation 2. You can use equation 1, that's up to you. Try to keep everything as simple as you possibly can to avoid making silly mistakes. Whichever one is simple for you. So now let's substitute negative 5 into, therefore 2 times negative 5 plus 11 equals to x. Plus 11 equals to x. Well, let's fix this. Therefore, 2 times negative 5 plus 11 equals to x, meaning that, okay, negative 10 plus 11, therefore x equals to, therefore negative 10 plus 11, negative 10 plus 11 equals to x, meaning that 1 equals to x. Therefore, x equals to 1 and y equals to negative 5. This is the solution. And that's how you solve that. Next question. Given the quadratic number pattern, we're dealing with a quadratic pattern. Important to note this, so your brain is focused on the correct one. Here is the number pattern, negative 3, 6, 27, 60. 2.2.1, determine the general term of the pattern in the form. So we're looking for the general term. We're looking for Tn over here. All right, so negative 3, 6, 27, 60. 2.2, 2.2, negative 6. Okay, is it negative 6 or negative 3? Let's see. Negative 3, 6, 27, 60. Negative 3, 6. Negative 3, 6. 27, 60. Oh, we're supposed to find the general term. Alright, before we find the general term, this is what we need to do. Create a net, very important. Alright, so 6 minus negative 3, that is 9. 27 minus 6, that will be 21. Then we've got 60 minus 27. Okay, let's just double check, but that should be 33. 60 minus 27. 60 minus 27. Let's go 60 minus 27. 27. And that gives us 33. Alright, 33. Meaning that the second level should be 21 minus 9. Let's go. 21 minus 9. That gives us 12. Okay, let's check 33 minus 21 just for your convenience, so that also gives us 12. So the second constant difference is 12 in both of them. All right, now we can now start finding the general term. 2.2.1, the general term. All right, we have 2a equals to 12, so let's find a. Therefore a equals to 12 divided by 2. That's where we start. We start from here. This is where we start. We start from here, then go up, and the last one on the same row, the first of each one, that's what we use. The first term of each row, that's what we use. So now a will be 12 divided by 2, which gives us 6. All right, now we go. This is 3a plus 2 plus b. 3a plus b. 3a plus b is equals to 9. Using that net, now let's solve for that. We know that a equals to 6, so we substitute that. Therefore, that will be 3 times 6 plus b equals to 9. And that gives us 18 plus b equals to 9. Meaning that therefore b equals to 9 minus 18. Therefore b equals to 9 minus 18, which gives us negative 9. Now for the last one, that is a plus b plus c. A plus b plus c equals to negative 3. Let's just double check, correct. Now let's substitute all the ones that we already have. So a is 6, b is negative 9. That'll be 6 plus negative 9 plus c equals to 3. Now this gives us negative 3 plus c, which is equals to 3. And that gives us, therefore, c equals to 3 plus 3, which is equals to 6. Now, therefore, the general term is 6n squared minus 9n plus 6. And that's how you find the general term. Next question, 2.2.1. Calculate the value of the 60th term, the 50th term of the pattern. So that is T50. That's what we're supposed to calculate. Calculate the value of the 50th term. 2.2.2. We're looking for T50. T50 is very easy to find. T50 is simply equals to 6 in bracket 50 all squared minus 9 in bracket 50 plus 6. Take out a calculator. So we have 6 in bracket 50 squared. Okay, we've got 6 in bracket 50 all squared minus 9 in bracket 50 plus 6 plus not divided by plus 6, which is equals to 14,556, and that is the answer, 14,556. Next question, 2.2.3. Show that the sum of the first differences of this pattern can be given by Sn, the sum of the first n terms equals to Cn, 6n squared plus 3n. Remember that the first differences is an arithmetic sequence. Alright, so let's go back. The first level of differences is this one, the arithmetic sequence. This is the level of the arithmetic sequence. We want to show that the sum of the first term of this arithmetic sequence is that answer they gave us. So that is 9, 21, 33. Okay, so the sum of the first n terms, so that is 2.2.3. Let's just double check, it's 2.2.3. We've got the arithmetic sequence level, and that has got the pattern. Let's go. The pattern for that is 9, 21, 33, with the second level of differences B12. 9, 21, 33. is, and the constant difference is 12. We want to find the sum of the first n terms. Our first term here is 9 and our constant difference is 12. And the formula for the sum of the first n terms is equals to n over 2 in brackets 2a plus in bracket n minus 1 times d. We don't know what the last term is going to be, so we use this formula. So that will be n over 2 in bracket 2 times. The first term is 9, so that will be 2 times 9 plus in bracket n minus 1 times d is 12. And now we expand n over 2 in bracket 18 plus 12n minus 12. And that gives us n over 2. 12 minus 18, that gives us 6. So that is 12n plus 6. And now let's multiply out. Okay, before we do that, let's factorize. Take out a common factor of 2. And that leaves us with 6n plus 3. Now this 2 cancels with that 2. And that leaves us with n in brackets 6n plus 3. Therefore, Sn equals to n in brackets 6n plus 3. Now if we multiply this out, that gives us 6n squared plus 3n. Let's see if it matches the answer they gave. Perfect, it matches the answer they gave in the question. So we can now go proven. The last question: how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060? How many consecutive first differences? First differences, that is the level that forms the arithmetic sequence, meaning the second level, were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. Now let me show you what exactly it is that we are talking about here. All right, they want to see, this is the first term of the quadratic sequence, -3. They want to see how many terms this level we added to find that number that they talked about. So to find the second term of the quadratic pattern, we need to add just one first level difference. Now to find the third one, we need to add 1, 2. To find the fourth one, 1, 2, 3. To find the nth one, we need to add n minus 1 number of terms. Now let's find what that term is first, the term number, so that we can just simply subtract 1, and that will tell us how many first level differences we had to add in order to get that. The number is 21,060. So 21,060. So that is 2.4. 21,060. 2.2.4. The nth term that we're dealing with is 21,060. We need to figure out what this term is so that we can find the number of the first level differences. So the general term of this quadratic sequence is 6n squared minus 9n plus 6. Now, so we now equate it to that. Therefore, this is equal to 6n squared minus 9n plus 6. Equate that to 21,060 Now let's take everything to the left hand side. Plus 6 minus 21,060 equals to 0. Okay, simplify. Take out a calculator. 6 minus 21,060, that is equals to negative 21,054. Negative 21,054, negative 21,054 equals to 0. Now to make life easy, use the quadratic formula to figure out what the n is. N equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Now when we substitute, that gives us, that is equals to minus negative 9 plus or minus square root of negative 9 all squared minus 6 times 21,054 all over 2 times 6. Take out a calculator. Let's take out that calculator and calculate this number. Let's take out the calculator and calculate this. Right here is the calculator. So we've got, alright, let's go. Common fraction button, there it is. So that will be negative open bracket, negative 9, close bracket, plus, we're going to start with a plus 1, square root of, right, open bracket, negative 9, close bracket, x squared, minus 4, open bracket, 6, close bracket, open bracket, negative, should be negative, yes, negative 21,054, negative 21,054, close bracket, downward arrow, 2, open bracket, 6, close bracket, right, equals to, and that gives us 59.99999. So that should be, what should it be now? What did we do here? I don't know what's happening here. I'm not sure what happened here, but we seem to have made an error. Let me try and fix it. Alrighty. Okay, let's redo this just to be sure. Okay, everything is now. Okay, let me delete everything. Let's start from scratch. So that will be negative 9 plus square root, open bracket, negative 9 x squared minus 4, open bracket, 6, close bracket, open bracket, negative 21,054, close bracket, downward arrow, 2, open bracket, 6, close bracket. Okay, and that should give us 60. Yeah, it is 60. Right, if you use an offline calculator. So that is equals to 60. And the other one that is negative obviously gives us an answer with a fraction. If you want, obviously you should be using your calculator to double check this, an offline calculator, and it should give you the correct answer without any issues. So the answer should be 60. All right, therefore we have 60 therefore n equals to 60 terms. Therefore n equals to 60, meaning that Tn equals to that 21,060. I mean T60. So meaning n minus 1 equals to 60 minus 1, which is 59, meaning that therefore the number of first differences added to the first term which is equals to -3 to reach 21,060 is 59 terms. And that is the answer to this question. Next question. Question 3 goes, prove that the sum to infinity of this geometric series is a convergent geometric series. Prove that this is a convergent geometric series. So we're dealing with a geometric series. A geometric progression, it's up to you. Show all your calculations. This is very easy. Remember, this is your general term, or TK. You can call it TN or TK. It doesn't matter which one you want to use. Now, let's look at 3.1. Question 3, 3.1. Question 3, 3.1. We're looking at the sum to infinity of k equals to 1 of, let's go back, 4 times 3 to the power of 2 minus k, 4 times 3 to the power of 2 minus k. We're supposed to show that this is a convergent geometric series. All right. Now for this to be convergent if your constant ratio is between 1 and -1. So we need to find what the constant ratio is so that we can compare if it meets this requirement. So T1 from there is equals to, we know that this is Tn, this is Tn. T1 equals to 4 times 3, we substitute to the power of, which is equals to 4 times 3 to the power of 1, which is 4 times 3, which is 12. That's the first term. Term number 2, that will be 4 times 3 to the power of 2 minus 2 equals to 4 times 3 to the power of 0. Anything to the power of 0 is 1, and that will give us 4. Now to find the constant ratio, all we need are these two terms. The constant ratio R, which is T2 over T1 equals to 12 over 4. Sorry, it is equals to, no, sorry, 4 over 12. T2 over T1, which gives us 1 over 3, which is 0, 0,3. This is a R equals to 1 over 3 is between 1 and negative 1. Therefore, the geometric series is convergent. The geometric series is convergent, and that's how you test for convergence. Easy peasy. Next, 3.2. If this, the sum to infinity, all right, for k equals to p, from k equals to p is equals to that, determine the value of p. Remember, this is the nth term. Okay, so this to infinity of k equals to p of 4 times 3 to the power of 2 minus k, this is equals to 2 over 9. If that is equals to that, we must find p. Remember, the sum from k equals to p to infinity of 4 times 3 to the power of 2 minus k, that is simply equals to the sum to infinity minus the sum of the first p. Remember, we are dealing with a geometric sequence that has got an r which is between 1 and negative 1, so which is less than 1, meaning that the sum of the first n terms, of p terms for that matter, will be, the sum to infinity is obviously a over 1 minus r. That will be minus a over 1 minus r minus, that will be a in bracket 1 minus r to the power of n, p over 1 minus r. And that will be equals to, so this should be equals to, if this is equals to 2 over 9, therefore this should be equals to 2 over 9. All right. Now the left hand side, let's substitute. A equals to 12. Remember the first term. A equals to 12. So that will be 12 over 1 minus a third. That's what the constant ratio is. All right. Minus 12 in bracket 1 minus a third to the power of p all over 1 minus a third. That is equals to 2 over p. 2 over 9, sorry. Now let's take out, okay, first before we take out any common factor. 12 minus 1 over 13. I just want you to see something here. It is a common factor, but I don't want to take it out just now so you can see exactly what's happening. So we've got 12 over 1 minus a third. 1 minus a third. Yeah. And that is equals to 18. There we go. So that gives us 18. Therefore 18, And here is another 18. So that's 18 minus, let me show you something. So we've got this, which is common to that. So we've got another 18 over here, and that is multiplied by 1 minus a third all to the power of p, which is equals to 2 over 9. Alright, so let's take out a common factor. The common factor is 18 over here. Therefore, 18 leaves us with 1 minus a third all to the power of p, which is equals to 2 over 9. Now, divide both sides by 18, so that leaves you with 1 minus a third all to the power of p, which is equals to 2 over 9 times 1 over 18. That leaves us with, okay, take out a calculator. Two over 9 multiplied by 1 over 18 and that gives us 1 over 81. There is the answer. You'll see why we need to leave it like that for now. That gives us 1 over 81. So now we can bring the 1 over 81 to the left hand side and then take this to the right hand side to deal with the signs. Right. Let's add another page. There we go. So what we do now is we take this to the right hand side, we take this to the right hand side. Let me show you. Take this to the right hand side so it becomes positive, and then bring this to the left hand side. Therefore 1 minus 1 over 81. Therefore 1 minus 1 over 81 equals to positive 1 minus a third all to the power of p. Now 1 minus 81, 1 minus 1 over 81, take out a calculator. One minus 1 over 81. Alright, that gives us an answer of 80 over 81. So that's 80 over 81. 80 over 81, and that is equals to 1 minus 1 over 3 all to the power of p. Now take this to the left hand side. We can take this to the left hand side and this to the right hand side. I'm playing with the numbers here. 1 over 3 all to the power of p equals to 1 minus 80 over 81, which is equals to see how you do this is up to you. 1 minus 80 over 81. Okay, calculator. How you manipulate the numbers is completely up to you. 1 minus 80 over 81. Here we go. and that gives us an answer of 1/81. Which gives us 1/81 can also be written as 1/3 to the power of 4, which can be also written as 1/3 all to the power of 4. Now therefore, because you've got common bases, you've got powers of the same base, that means you can simply equate the exponent. Therefore, the answer is P is equals to 4. Therefore, the value of P is equals to 4, and that's your answer to the question. Therefore, the value of P equals to 4, meaning that therefore the sum of K equals to 4 to infinity of 4 times 3 to the power 2 minus K equals to 2/9. If you don't believe me, let's calculate that if you can. Alright, so we can go back to this is equals to sum to infinity of 4 sum to infinity minus the sum of the first 4 terms, that is equals to A/1 minus R minus, this is us checking, you don't have to do this, A in bracket R1 minus R to the power of 4, that is P/1 minus R. Okay, now let's so that will be the first term was 12/1 minus a third minus 12 in bracket 1 minus a third to the power of 4 all over 1 minus a third. You can calculate this and you will see it will give us the answer 2/9. Just want you to see it for yourself. So that will be 12. We're just checking the answer. The answer is correct. So that is common fraction button 12/1 minus another common fraction button, a third, right arrow, minus common fraction button 12, open bracket, 1 minus open bracket common fraction button 1/3 1/3 right arrow, okay, right arrow, close bracket, x to the power of y, we've got 4 there, okay, right arrow, close bracket, downward arrow, 1 minus common fraction button 1, downward arrow 3, okay, let's right arrow, and now we have equal to, and there you go, it gives you 2/9. Checked, and that is the correct answer. We've come to the end of this video. Thank you so much for watching. I'll see you in the next one. Bye-bye.